Section 1.9, limits determined by tables, has us trying to find the values of limits using tables. Not very complicated. So we look at a limit that we're trying to evaluate, and the important thing is to notice what value is x approaching. Well, we see that x here is approaching 0. So the use of a table can be nice if we're having trouble finding a limit, or if we're given a table of data instead of a function. So what you'll notice is that there are two rows. There is a row with our x values, and then there is a row with our function values. So we're going to fill out this function value row here. Now notice what's happening to x. So we've got x is negative 0.1, then negative 0.01, then negative 0.001. And we keep getting closer and closer to this value of 0. We're never going to get there, but we're going to get close. And then if you look from the other side, we've got 0.1, 0.01, and 0.001. So we're getting to 0 from that side as well. So we're kind of squeezing and zooming in. And so what we're trying to see is that right here, right in the middle, what we're seeing is what value is this function approaching. Now, in order for the limit to exist, it's got to approach the same thing from both sides. So what we kind of have here is on this side, we kind of have here the limit as x approaches 0 from the left of the square root of x plus 3 minus the square root of 3 over x. And then from the other side, we seem to have the limit as x approaches 0 from the higher side, or the upper side, of x plus 3 minus the square root of 3 over x. So this is kind of just the numerical look at this type of thing. So how do we do this quickly and easily? Now, your calculator can do this very well for you. So I'm going to boot mine up. So I'm going to show you a nifty trick that'll save you some time. So if we get our function typed in, so make sure that you have things in proper parentheses. Your numerator should get its own parenthesis, okay, around it, because there are two terms there. So make sure that's all typed in correctly. And when we graph it, we may or may not see anything of use. Now, you can go to second trace value and type things in, but I'm going to show you a different way. Now that since I have it typed into y1, I'm going to do function notation, and you'll see why that's going to be nice here in a second. So what I need to do is I need to go down, hit vars. So this key, go to y-vars, and click function, and the first thing that's going to come up is y1. Well, what I can do is function notation now. I can just type in whatever number I want to plug into x. So if I want to plug in negative 0.1, type it in, and it gives me 0.2911. Now if I want to do that again, I can just hit second enter and see how it brings up whatever I just typed in last. And see, then I can type in negative 0.01, 2.889, or 0.2889. And then second entry again, 2.01. Now this is plugging this is taking these values in the parentheses and plugging them into x. 0.2887. So we can see that this number is kind of dropping ever so slightly down. Now if we look on the opposite side, to say negative, and I'm going to do it this way. I'm going to say 0.1. I'm going to plug 0.1 in. So 0.1 gets 0.2863. And the reason I'm doing this way instead of going straight down the line is that you can see if the value of the function is approaching some sort of number. So 0.2884. So the number got a little bit bigger going that way. And then lastly 0.01. 0.2887. So once we fill in the table, you can see that our numbers seem to go down this way and seem to go up this way, and it seems to be matching around a value at 0, right? So notice that that's where we're looking, right? We're looking at 0. So when we pick our numbers, we're picking them right around whatever value x is approaching. So we can see here that we've got 0.2887. Now, we could also find this analytically, but if we're using a table, we can figure out, does the left-hand limit and right-hand limit agree around the point? If so, then our limit's going to exist. If not, then it won't.